Setting up. All right, and it looks like we are live.
Yes, that's when I turned off my phone.
Cool.
Great.
All right, welcome everyone to Sommers-Bausch Observatory. This is our weekly, well, it used to be weekly, right now it's our monthly open house event on Fridays, where we are glad to host you guys on a journey through the sky. So tonight, my name is Gilly. It's always Gilly. My name is Gilly, and this is my associate, Aaron. And
Hello.
tonight, we're just going to be pushing the buttons and making the telescopes go. This is the telescope we're using tonight. It's a 22-inch now telescope, and I'm actually just going to start that one moving right now.
So if you look behind us, you should see it move to our first target slowly.
Yeah, and before I hand off this session to some of our friends here, let me just show you the way that we do this. We have a map of the sky here, and anything in this orange circle is above the horizon. So we're going to try and get Uranus right before it sets. But tonight, I'm excited to introduce to you the CU Stars. It's another group here at CU who is going to be doing the science behind the targets we're going to be looking at tonight, and sort of explaining to you kind of what we're looking at. So I guess I'm going to hand it off to them, and we'll be back here making everything go.
Right, I wanted to start out. My name is Erica Ellingson. I'm a professor in the Department of Astrophysical and Planetary Sciences at CU Boulder. The telescopes that you see behind Gilly and Aaron are actually telescopes at the observatory located on the campus. And we're really sorry that you can't be here tonight to actually look through the telescopes in your own eyes, but we're hoping we'll be able to share some of the images, share some of the beautiful things that we see in the sky with you tonight. I am part of the CU Stars, where STARS stands for Science, Technology, and Astronomy Recruits. We are a group of undergraduates, graduate students, and other people in the astronomy community here at CU. And what we do is on most years, we travel all over Colorado and bring our enthusiasm for the sky, for the heavens, for the planets, stars, everything about space to schools all over Colorado. And tonight, I'm hoping we'll have some of you joining us from some of the schools that we visited in the last couple of years. So I want to do a welcome. If you've seen the stars before, you'll see some familiar faces from perhaps a previous visit. And if you haven't met us in person, I'm hoping that we'll be able to come and see you for real sometime soon. So all of the stars are undergraduate science majors, and the stars we have here to help out tonight, why don't we just give them a chance to say hello. So let's start off with Christina.
Hi, I'm Christina. I'm a sophomore here. I'm an astrophysics student, and I love space. It's amazing.
Next one on my screen is Philip.
Hi everyone, I'm Philip. I'm a senior astrophysics major, and I study particle acceleration, jet launching, and accretion with numerical simulations of supermassive black holes at the center of almost every galaxy.
Okay, Patrick.
Hello, good evening. My name is Patrick. I'm a junior in the department, and I am interested in planetary sciences, but most of my work is in solar physics.
Okay, Noah.
Hi, I'm Noah. I'm a junior astrophysics major from Las Vegas, and thank you all for joining us.
And Eris.
Hello, I'm Eris. I'm a sophomore majoring in astrophysics and math, and in the future, I hope to study the theoretical side of astrophysics.
Okay, well, thank you to all the stars for coming here tonight, and thank you for Gilly and Aaron, our graduate students here in Boulder, for being actually at the observatory and manning and running the telescopes for us. So we have a big, long list of things that we'd like to share with you. And so let's get on the sky. Gilly and Aaron, where are we going? And take us there.
So yeah, we're going to start with Uranus because it's just about to set. And here I've actually already begun taking the picture just because it's so close to the horizon. But this is Uranus, yeah, the planet Uranus, and it's kind of cool. You can see how it's brighter at the center and less bright at the edges a bit, as opposed to just being a point, which you would get if we were looking at a star maybe.
Hey, Gilly, what's that in the bottom left corner?
Oh, this right here? Yeah, when you see really sharp-edged things like that, really square things, you can usually be sure that that's some sort of artifact coming from the camera. So in this case, that's probably a pixel that's just stuck a little bit too hot, a little bit too bright. Yeah, this is right now taking half a second exposures and stacking them to get this nice little dot here. Let's look at a star, what it would look like.
Are we
A
not
little bit
sure
of
if
a
those
disk
might
there
be the
too.
moons? I don't know.
That could be a moon.
It's hard to tell the distances when we're looking at the photo like this.
So we've got a fuzzy dot that is Uranus. I think Patrick has a couple of things to explain to us about Uranus. So why don't we give him the mic?
Yes, I do. So Uranus is the unfortunate brunt of many jokes, but it's the 7th planet in the solar system. It's the second furthest out. Only Neptune is further out. And it was actually discovered in 1781, which is a bit later than some of the other planets like Mars that we've known that have been planets for a long time. It's about 2 times further from the sun than Saturn is from the sun. So it's like it's way far out there, which is why if you look at it with your naked eye, you're only going to see just like a little dot. But in fact, when people started observing Uranus, they actually thought it was just a star. They didn't realize it was a planet. And it was only until William Herschel, he looked at Uranus through his telescope, and he actually thought it was at first a comet. And after much debate, they, I guess, came to the conclusion that it was indeed a planet. But what he said was, in March 13th of 1781, so the 240th year or anniversary of discovering Uranus is actually coming up soon. But he wrote in a journal saying that he thought it was either a nebulous star or perhaps a comet. So it wasn't clear at all that Uranus was a planet because they didn't have all of the fancy telescopes that we have today. But yeah, so after much debate, Uranus was officially registered as a planet, but it took about 70 years until they officially got the name of the planet down. Because originally, the discoverer, William Herschel, he wanted to name it after the King of England. He wanted to name it Georgium Sidus, which is George's star.
Name it George.
Yeah.
Sorry.
And so he wanted to pretty much name it George. Yep. And it didn't gain much traction outside of England, so it never really stuck. Some other people wanted to name it after Herschel himself. That never stuck either. Other people wanted to actually name it Neptune, which obviously it wasn't named Neptune because we have another planet named Neptune. But they settled on Uranus, which means the Greek god of the sky. And Uranus was the grandfather of Jupiter and the father of Saturn, which is actually quite fitting because it goes like Jupiter, Saturn, then Uranus. So it makes sense that Uranus would be the grandfather of Jupiter and the father of Saturn. So yeah, some just stats about it, I guess. It's about 4 times larger than Earth, but it's not very dense. It's composed of a bunch of ices on top of a rocky core, and then it has a super gassy atmosphere. And because of the orbital dynamics of it, only one pole points towards the sun. And so for one side of the planet, it's summer, the equivalent of what summer would be, and the other side just gets no light at all. And so the atmosphere can get nearly 400 degrees below zero, which is which would make it the coldest atmosphere in the solar system. And that was kind of all I had to say about it. It takes about 80 years to go around the sun. So we don't see too many changes in it from day to day because it takes so long to go around. But yeah.
All right, that's great. We're hoping that any of you who have joined us will ask any questions you have on the YouTube chat window. I have to say that there is a significant delay between what we're doing here at the observatory and in the stars, realm of the stars, versus what YouTube is showing you. So if you ask a question, please have a little patience for us to answer it. We will catch up with any questions that you have. Okay, our next object is also a planet. Off we go, guys.
Sure. Okay, so I think we're doing Mars next, if that's right.
Oh, and perfect timing too. It's right. Uranus is just out of range now. Perfect.
Yep. There's Uranus center. So we're just going to slew the telescope over to Mars. Click the slew button. And
which
there
is
she
astronomy
goes.
for move.
Mm-hmm. Astronomy speak. Click. All right. Back to the camera. And 60 seconds is not correct. Let's actually, I really do love this tool. So let's do half seconds. Again, blah, blah, blah. I guess we can do Mars. This is the red planet, right? Okay.
It is the red planet. It is a planet which needs no introduction almost, especially recently with
not enough stars found.
The Perseverance rover, which I think we will hear a little bit more about from our stars here once we get the image on the screen. It should be quite bright.
That's what I was thinking.
Try the red filter.
Yeah, it's been saying.
So we have these different filters that are on the telescope that will emphasize or allow to pass different ranges of light, and we're just trying to find the best one for the target. This R and G that we're referring to is basically just visual light, and I think we also have some filters that will look at ultraviolet light and infrared light, which is like, if you have like a hot burner on your stove, that's infrared because it's producing heat, and ultraviolet is, of course, the thing you need to worry about getting sunburns from. But we can also look at them using our astronomical tools to study these objects.
There we go.
Okay, that's looking pretty good. It's looking pretty bright.
Too bright. Okay, we'll try a 0.5 seconds and go.
Ah!
All right.
Okay.
It tries.
It's quite bright. You might want to go even less, honestly.
Yep. 0.5. And we ratchet down.
I've also looked at Mars through the H alpha filter, and I think that looked pretty good as well.
Ooh, we could try that.
There, that's a planet. It's a circle.
So you can see that it's being cut off down here.
Yeah.
Which is no good. So yeah, let's try. Armed with that knowledge, I can come into here. 0.0.
Do you want to change the
1?
Oh, we're not doing that when we're doing the binning or the stacking. Did that work for the last one?
We'll see.
No, try the H alpha.
Okay. Click.
I think it was H alpha.
Interesting.
Can you increase the exposure? You might want 0.1.
Okay.
I'm trying to recall what it was last time.
Yeah, this tool is not working on Mars, but so here, here's Mars. let's ratchet down even more. So 0. I think here, and go. We just want to. Oh, okay. Staying bright. Can we do one more? I'm not sure we can.
No, I think this is the limit.
Yeah. Can I not set one of the filters here?
Did you want to take the auto dark off or something? Does that help?
I like auto dark.
The filter wheel is right here.
Yeah,
If you
so
need to change that.
oh, that's cool. Okay, so now if we take the picture.
We mostly tested this filter stuff with the live stack. There we go. And we didn't test it on the regular exposure, but I think we've got it going now. It looked pretty good initially. I think that was fine.
It seems kind of ironic that the brighter the object is, sometimes the harder it is to take a picture of it.
Yeah, this stuff is not designed for.
There is Mars. All of our pictures are unfortunately in black and white, so everyone should imagine that you're actually looking at the red planet. And I hope everyone's been watching the news, because there's some really exciting things to do with Mars. And I think Noah is on board to let us know about it.
Yeah, so I'll be talking about Mars for a bit. So Mars is the 4th planet from the sun. It's also the 2nd smallest planet after Mercury, and is named after the Roman god of war. It has 2 moons, Phobos and Deimos. It takes 687 days for it to orbit the sun. It's red because of iron oxides that cover its surface, and iron oxides are basically rust. And then Mars also has a lot of weather. One of the big things it has are massive dust storms that can cover the entire planet for months at times. We've sent 5 rovers now to the surface of Mars. Of course, the newest one is Perseverance that just landed a few weeks ago. And Gilly, could you unshare your screen so I could share the video? Let's see. All right, so I have a clip of Perseverance landing on Mars.
Relative navigation, current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
So that's a really cool video, and just really special that they were able to capture that. Now here's a couple of pictures that the rover has already taken. Here's the most recent image, and looks like it just started moving. You can see the treads over here from its tires, so that's pretty cool. I encourage everyone to go watch the entire video and just go look at these pictures, because it's just really cool stuff. Also, the rover has a bunch of different experiments it's going to try on the surface of Mars. A lot of them are aimed at trying to see if there was past life on Mars, so it'd be cool to see what kind of results they get from that. So any questions you have, go ahead and put it in the chat.
Okay, are we ready for our next target then? Or are there a lot of questions coming in, Philip? I think you said you were watching the chat.
Yeah, I just saw a question there. The question is, why are we looking at pictures rather than just looking through the telescope live? That's kind of a technical question, which I can take unless one of the C stars wants to talk about that. Yeah, okay. Basically, you are just looking through the telescope live. The photons from space are coming into the telescope, and then they're coming and hitting this detector in the back. So, you can't really put your eye there right now, but the camera is in exactly the spot where your eye would be. Now, we can set it up to take pictures quickly, where, here, I'll even show that. We could set it up to make it sort of be more like a movie. I've got this thing called Focus Tools, and it takes a photo every few seconds. It brings up the newest image, And we could do it that way, but really with stuff in space, if you want to see these really faint objects, we want to take one picture for a long time rather than more of a video.
Yeah.
So right now I'm about to take a longer exposure of one of these other objects, one of the next objects we're going to get to.
Yeah, the nice thing about doing it this way too is that if you were here in person and you were looking through the eyepiece, as is very fun to do, a lot of the objects that we're going to look at tonight actually wouldn't really be visible with your eye because they're so faint. Your eye just can't gather the light like effectively enough, fast enough to resolve them, to see them. So with the camera, we can see images that are quite a bit dimmer than you could see with just your eye.
Yeah, so that's an 11-second exposure. Let's see what a 100-second exposure does.
Well, that'll be a while.
Yep.
So you guys will have a consolation prize, even though you can't come and be with us on the cold winter deck, effectively outdoors at the observatory. You do get to sit in probably a warmer place and watch these guys do all the work anyway. And you will be able to see things that we probably wouldn't even try to show you if we didn't have the camera here to take longer exposures and show you what things look like. I also want to say thank you to the weather. We tried to have our open house last week and the weather was absolutely uninspiring. And so I'm hoping that if you had planned to be with us last week, we're very happy that you came and joined us this week instead. The weather at Sommers-Bausch Observatory is extremely nice tonight. The stellar images look very stable. There's a little bit of haze at sunset, but I think we're getting about as good a viewing as we might be able to hope from downtown Boulder. If any of you are joining us from places where you have darker skies, I want to let you know we envy you. So how's that exposure going, Erin and Gilly?
We got about 30 seconds left on that one.
About halfway through.
And you can see what we have right now a little bit in the current exposure. And then once that one finishes, I think it should be pretty dramatically different.
So this object is the Orion Nebula, and Eris was going to tell us about it. And so maybe they could start and get going on the narrative.
Yeah, sure. I was mainly waiting for the image to finish so I could try pointing some stuff out, which it should be. There we go. That, I don't know, I really like that image.
Wow.
It's very pretty to me. So,
yeah, I wasn't expecting that. Wow.
This is looking really good.
So this is, specifically, this is the trapezium of the Orion Nebula, which is an open cluster of stars in the very heart of it. Open clusters are usually found in the plane of our galaxy, and primarily in the bright spiral arms, like what you see when you look up on a very, very dark night. And each open cluster contains like thousands of stars. Over time, these stars will spread apart and scatter through the galaxy. The open clusters are also part of the reason why the spiral arms of both our galaxy and others glow so brightly, because they are host to the materials that stars need to form in the form of nebula, and are therefore home to many more young stars and also many more bright, more short-lived stars as well. So they sort of stay in the same position in the spiral and keep the spiral there instead of the spiral gradually disappearing or merging into other parts of the galaxy. So in addition to, there are two types of star clusters that astronomers use. So open clusters, which are what we see here, are typically used by astronomers to study star formation and how material spreads around the galaxy. And then the other type of star cluster is a globular cluster, which contains some of the oldest stars in every galaxy. These are usually scattered around the galactic halo, which is the area basically that's not in the plane, so everywhere else. And these stars are almost as old as the galaxy itself, so the astronomers find them very useful when studying the state of the early Milky Way and the state of early stages of other galaxies. The trapezium itself was discovered by Galileo, And actually, with a small telescope, like just 5 inches in diameter, amateur astronomers can see 6 of the main 8 stars that illuminate this part of the nebula, with the 5 brightest stars being between 15 to 30 times the mass of our own star. In addition, a recent paper suggested that there may be a black hole with the mass of 1,000, no, sorry, not 1,000, that's a lot, with a mass of 100 times that of our sun within the trapezium. And we can sort of tell this because of the variation of the speed that the stars are moving out of the nebula. And again, the trapezium itself is part of the Orion Nebula cluster, which has around 2,000 stars and a total diameter of 20 light years, meaning it would take you 220 million years to drive across it at 60 miles an hour. Yeah, I believe this can also be found in the Sword of Orion, the nebula as a whole. So if you have a very dark sky and a small telescope, you can take a look for yourself. And then I'll also be happy to answer any questions that occur in chat.
That was fantastic, Eris, and what a gorgeous image. Gilly and Aaron, we have another really lovely thing coming up. Are you ready to zoom away to our next target?
Yes, we are. We actually already slewed. I'm just about to hit take photo. Click. So yeah, the next one we're doing the Crab Nebula.
M1, right?
It might be M1.
I think it's M1.
I'm inclined to believe you if you assert that. Let's see. So we've got 40 seconds left on that exposure. Wow, this just wants to be on top, doesn't it? There we go.
We only have 2 monitors here and about 10 windows, so
you'll have to
excuse us if weird things pop up. We're trying to organize them.
So yeah, we were just here in the Sword of Orion, definitely a sword. Up to the Crab Nebula we've gone. Now, and how much time do we have left? 16 seconds.
For any of you who are joining us on YouTube, I don't know if any of you guys come from our partner schools, but if you do, if you could type in your school, we'll give you a shout out and a little applause, and I'll tell you teachers you came to.
What have we here?
Pretty dim, pretty fuzzy. I'm starting to see the shape that I remember from pictures. Oh, it was really good just then.
We need a deeper exposure, it seems like. Let's see if this guy works again. Maybe with 5-second exposures. Not 65, that's too much.
That would be a lot.
5-second exposures.
Maybe not H alpha.
Yeah, let's just do the green filter.
I'm not sure which one is good for this particular object, but we'll give it a try.
Yeah. Boop. You work. Oh, there we go. Okay, at least it's working this time.
Okay, so as the software stacks these photos together, it should become a little clearer. Perhaps.
Maybe. We're only at 15 seconds, but usually you don't get to see it build up like this. Usually you just let it sit and go for 100 seconds or 200. So I'm interested to see if it works the same way.
I see a slight patch. It may not be the best filter, but we should definitely let it run a little bit more to test.
Mm-hmm. I do wish I knew how to turn off all the filters.
For it. I'm not sure actually. And just collect all of the light.
Just no filter. Hashtag no filter. Hello, fellow kids. No, it doesn't seem like it's really coming out.
No, I think
like
this
I was
is not the
hoping for.
best filter. So try the. Do any of the stars have a suggestion? I would maybe try the U, but I'm not an expert at filters, honestly. I'm a planetary scientist. I actually study Mars. And the weird thing about doing planetary science is we often don't really use telescopes very much because we have these missions, fortunately, that can go to the planets.
Oh yeah.
Not to say that people don't use telescopes, they certainly do. It's just maybe less common than for astronomy, where you have no choice but to use telescopes to look at these very distant objects.
I'm going to suggest that you never use the U filter. It's far out in the blue, and the camera is actually not even very sensitive there, and a lot of objects.
Yeah,
don't
and look at this
absorb a lot of
interesting
light.
bokeh.
And
This
so-
is the object we're trying to see,
Yeah.
but it's not doing great.
Well, it's better than the G,
Better to
but
come up.
not great.
Yeah. So what filter would be good for the crab?
I would still go for R. Is my favorite filter. There are some filters that are tuned to just look at colors that the exploding gas gives off for some of these nebulae, but I'm not sure I would go with that for this particular case. And so I would stick to the filter we call R, which is sort of a reddish visible light, and just sit on it for a while. It's a faint object. And it's one that if you were to even just look through the eyepiece of our large telescope, you might walk away and go, yeah, whatever. And so whatever we get here actually is already starting to look good to me. And so if you could pull up that first image that you had or take another one just like that, I think we can go on.
Yeah, that was the 60-second image. I think that might work better than this slow build-up process. Maybe.
Is there a way to move this aside and bring up the other photo?
Let's see. Here's the other photo. Yeah. So maybe that's still going in the background. See, this was with G at 60 seconds.
All right. So that actually looks like a pretty nice image. I can see it's actually kind of got some fringy, filamentary stuff. So Christina, do you want to let us know a little bit about the Crab Nebula?
Absolutely. So the Crab Nebula is a supernova remnant. So what happens with those is when a star, a very, very massive star, gets near the end of its life, what happens is it gets smaller and smaller and smaller, and then it bounces off of the core, and there's this big explosion with lots of hot gas. And in the middle is left behind either a neutron star or a black hole, depending on how big the star was. And so what we're looking at is all the hot gas left over from that supernova. The really interesting thing I think about this object is that when it went supernova in 1054, it was actually bright enough to be seen during the daytime for a couple of weeks. So people could look up in the sky during the day and see this really bright star. And it was very well documented by Chinese astronomers. They referred to supernova as guest stars. And they were considered either a good or a bad omen in favor of the current emperor. So this specific 1054 supernova was considered a sign that the emperor was doing a good job. There aren't any European records of this supernova, which is really interesting. We're not really sure why. Could be it was just cloudy for a couple weeks. But it's possible that it was documented by some petroglyphs in Chaco Canyon, which is in northern New Mexico. Because we have these petroglyphs that feature a hand, a crescent moon, and a star. So it's thought that this might represent the supernova event. But we're not really sure. We don't know exactly what those mean. So if anyone has any questions on this object, I will do my best to answer them in the chat. But
All right, we're ready for the next one then. The supernova is one of the biggest bangs since the biggest one at the very beginning. So I hope you guys enjoyed having a look. Gilly and Aaron, are you ready for the next object that we're looking for? It is the galaxy NGC 2903.
2903, thanks. Yeah.
We are searching for it.
2903.
We're getting away from things that have names and now to more obscure objects, still as beautiful, that just have numbers.
Oh,
Wait, where is it?
It's in here somewhere.
Oh.
There it is.
Oh, okay.
All right, and Slew. Here it is, chucking over. Cancer, Leo. Guess we're going to be in Leo.
There we go.
Let's start with 120 and see what happens. And go.
This is the
It's a galaxy,
Barn
right?
spiral, I think, yeah.
Yeah, so we want to give that a nice long exposure off the bat. But we could start talking about what it is, maybe how far away it is, stuff like that.
Yeah. So Philip is on for this one, and maybe not only talk about what we'll see, but things we can't see.
Yeah, and do you want to share your
Yes.
screen?
Yes, so I will be talking about this this galaxy. So NGC 2903 is a galaxy that is quite far away. It's about 30 million light years, which means that light emitting from there will take 30 million years to arrive at Earth. And it is a galaxy, which means it's composed of hundreds of billions, even trillions of stars. So like us, we are like the sun is inside the Milky Way galaxy, and this galaxy is very far away from us. Also contains many stars, and like when we were talking about Uranus, we talked about that William Herschel was the one who proposed that it's a planet, and this galaxy is actually initially discovered by William Herschel as well. And when the image comes, you'll be seeing the spiral structures of this galaxy, which looks like little arms, and you'll see a very bright center, which is called the bulge of a galaxy. And at the center of the bulge of a galaxy usually dwells a supermassive black hole that is that can be billions times the mass of our sun. So, yeah, so you can see the image of the spiral galaxy right now, and it's actually very pretty. So you can see the gas swirling around the galaxy, and in an arm-like structure above and below the brightest spot at the center, and those are called spiral arms. That's where the majority of the stars in the galaxies are concentrated at. And at the center, you see a very bright bulge, and it hosts a supermassive black hole that is very heavy, and there's almost in the center every galaxy will be a supermassive black hole. And when things spiral into a black hole, the chances are that they will probably never escape from it, because not even light, the fastest thing, like the fastest thing in the universe, can escape from a black hole. And in the galaxy, you can see that there are sparkling stars, there are glowing bursts of gas, and there are these dark regions that are obstructed by the dust in the galaxy. And looking at this picture, you may wonder, like, in these hundreds of billions of stars in there, will there be one that has life on a planet that's orbiting it? And I think there will be many wonderful things happening right now in that galaxy.
That's great. Thanks, Philip. Send your questions in on the chat. Philip's a real expert on black holes, and there's a lot of interesting things that he can tell you about them, as well as any of the stars on any of the other objects that we've looked at tonight. Aaron and Gilly, are we ready to roll on to our next object?
All right, yeah, let's do that. Did you see
1893.
1893? Click. Let's see, we'll center on it.
Make sure
Ooh.
it's in view still.
Yep.
Great.
We're still in
Right
view.
on the ecliptic.
All
Beautiful.
right, center and slew. So what is this? We're looking at an open cluster.
I want to say that almost everything that we've looked at tonight is been sort of stepping out through the universe. We started off with the solar system, with first Uranus further out and then Mars, but then a couple of objects in our own Milky Way galaxy, and then NGC 2903, that spiral galaxy, was the first thing we looked at that's actually outside of our own galaxy. You might remember is located much, much further away. With this one, we're going to pop back into the Milky Way.
Probably will
and
need
then
a super long
the next
exposure.
few objects we do are going to be other objects that we see in the Milky Way, and sometimes in the actual Milky Way we see as a band across the sky.
All right, so 1 second is not long enough, probably. Let's try 10.
Well, it's just the open cluster, so, well, I guess it depends on how dim the stars are,
Yeah.
how bright, as it were.
What is... That one's not very good.
I wasn't ready.
Yeah. Ooh. I wish this was working better. But...
These, so typically you should be able to see this just fine with your eye too, so we shouldn't need a very long exposure. That looks pretty good though.
Seems like there should be more going on here.
If they're quite dim, they might be getting washed out as.
I can try a longer one.
Oh no, I was thinking
Shorter?
shorter, but go ahead and try a longer one.
Let's see what 30 seconds gives us. Beep. And it looks like there's lots of little objects in this vicinity, actually, we could point at.
This is, as Gilly and Aaron said, an open star cluster. And while we're taking a longer exposure, maybe pick up a few more fainter stars. I think, Patrick, are you on for this one?
Yes, I am. So we heard a little bit from one of the other stars about some clusters of stars. We looked at the Orion Nebula, and this is going to be another open cluster. And so one of the main traits of an open cluster is that they're all born around the same time. And so that gives a lot of interesting science behind that, because you're able to look at a bunch of different, like, composite, or not necessarily composition, but you're able to look at a lot of different properties of the stars in the cluster and kind of compare and contrast them, because they're all born from the same cloud of gas. They're all born around the same time. And so some interesting science can come from that. And most of these clusters, well, all of the clusters are born from a big giant molecular cloud that just kind of starts to contract a little bit. So you can just imagine a bunch of dust floating in space, and then some bits of these dusts, they kind of clump together, and that kind of creates a runaway effect in which all the material combines, and then it creates a star as we know it. So I think I have an image that's taken from not our telescope that I can share real quick of the cluster. So here is an image that is taken, and I saw in the chat earlier, someone asked about the color of the color of these images. And like you can see, there's a little bit of red, blue here, and that's mostly just false color. So you can take color from different wavelengths, different filters, etc., and you can combine them all. And then sometimes they just create different color schemes to make it look pretty. but you can see in the 7 o'clock position, I'm not sure if I can annotate or anything like that, but you can see there are two little clumps down in the like maybe 8 o'clock, 7 o'clock position of the nebula itself. And those are going to be clumps of dust that congregate and they create stars. That's where all the star forming occurs. And you can see on the inside there are a bunch of stars that have been born. Yeah, that's kind of all I have new about clusters, because we already heard a bit from one of the other stars about the Orion Nebula. But yeah, I'm not sure if we have an actual image from our telescope yet. Any updates?
For which one now?
For NGC, when we're
Yeah.
1893.
I can pull that one back up. This is why I saved them.
We just already began trying to get ahead and take an exposure on the next one, but we've got the open cluster here.
Yeah, so you can see a bunch of the congregations of stars. Those are a lot of new stars forming. They're generally, they all are formed around in the same space. So that's kind of what you're seeing there. Yeah.
Great, thank you, Patrick. So how are we doing on our next object? You guys zoomed along while we were looking at the open cluster.
Yeah, it turns out that they're right next to each other.
Good.
I see not going anywhere. Here it is. Yeah, this is what we looked at, something just here in it, and the next one's right here. So this is what I just got on a 30-second exposure. This is the IC 405. Do we want to do a deeper exposure? Is this supposed to be a diffuse object, or what are we looking at here?
I believe this should be fairly diffuse, right?
What do you think, Christine?
It's a nebula.
Take on?
So if it's a nebula, why don't I put the hydrogen alpha? Why not? Who knows? Maybe that'll be cool. Camera. And we'll try. No, we should probably do longer.
Yeah, 45, 60. Yeah.
All right, and go.
All right.
So that's one of the things about astronomy is a large part of it is really just waiting as the light rains down into our little electronic buckets.
So Christina, do you have something to tell us about the Flaming Star Nebula?
Yes, I do. So the Flaming Star Nebula is a star-forming region. They're also sometimes called molecular clouds, and they're basically these giant clouds of dust and gas. So what happens in these nebula is that the sections of this dust and gas start to kind of clump together. And as it clumps together and the mass increases and it gets bigger and bigger, the temperature also increases. And when the temperature gets very, very high, hydrogen atoms start to collide and form helium in the process of fusion. And that's what causes young stars to shine. So that's what's happening in this nebula that we're going to look at. This specific nebula is about 1,500 light years away and probably about 5 light years across. And if we were able to see it in color, it would appear in sort of a reddish bluish color. But yeah, if you have any questions about it, type in the chat.
Structure.
Yeah, I'm not seeing a whole lot of nebula in this case.
I think I faintly see it, but it's hard to. I have to sort of move around.
Well, shall we move on? Maybe have another look at another nebula. Next one on our list was called M78.
Is it still exposing?
That's fine.
That one aborted. Oh, it was on the auto dark. I thought it was on the.
Yeah. Find bright nebula. Ooh, this one's bright. Yeah, center. And it's back near Orion, so we're on the sky. And flew. actually quite loud as it moves. Back into Orion's belt.
When people are here in person, we have to make sure they stand clear when we're slewing because it does move around quite a bit.
Let's see if I can get a quick one first.
I was about to say, could we try the R filter if that one doesn't come out too well once it's done getting the thing?
There we go. Yeah, that was too short to get anything. All right, so filter wheel back to R, and we missed this. Maybe not quite a minute and a half. Let's see if there's a synthetic image here. That's kind of cool. But what is this?
What is this object again?
It's called a bright nebula.
M78.
I think this is some sort of thing here going on.
So that bright region is what is part of the illuminated nebula. Well, I can just start talking now, I guess, from this. So this is a reflection nebula, meaning if we saw it in color, their colors would be more similar to the stars actually in the nebula, since it reflects the light of the stars instead of emitting its own light. So on here, you can sort of see a dark like arch of a shadow. So this is part of the interstellar dust that allows stars to form. And the very, very bright region is one of two very bright blue stars that formed in the nebula. So that those two stars, among others, are what mainly gives its color and also its brightness. So I'll just see if we can get an image before
15 more seconds. Yeah, just about there. Now let's see what we can pull out of this. Bring this here. Yeah, so you can see that arch kind of.
Yeah, and you can see some of the very bright stars. Among the stars in this nebula is host to about 45 forming variable stars, which are stars that change their brightness, which astronomers usually call luminosity. There are two general types of variable stars, which are intrinsic and extrinsic. Intrinsic variable stars are stars whose brightness physically changes due to pulsations, eruptions, through swelling or shrinking, or even when two extremely close stars exchange mass or part of their atmosphere. So an example of this would be a nova, which is different from a supernova. A nova occurs when a white dwarf, which is a possible end to star's life, usually with stars like roughly the size of our own sun, has a very close companion star. Once the two stars are close enough, the white dwarf can start to steal some of the matter from the other star. Eventually, enough mass moves onto the white dwarf that the heat of the white dwarf's surface ignites the new mass and sets off an extremely bright explosion of light, which categorizes it as an intrinsic variable star because there's a very sudden shift in its brightness due to an eruption. The other category of variable stars are extrinsic, which change brightness because they're being eclipsed by a companion star or a planet. So these may hint us towards possible stars that have exoplanet systems or other binary star systems. The nebula as a whole would take you around 110 million years to drive across at 60 miles an hour, or about 10 years if you're driving at the speed of light somehow. And just a little extra fun fact for the road, this nebula has also appeared in two works of fiction, both times being host to a star with a planet that hosts or has hosted humanoid aliens.
So Eris, what's the likelihood that that last one is correct?
It depends. With the variable stars, it would be less likely due to their variation, their luminosity, which would rain havoc on any life that was trying to form, particularly plant life, because it would basically be it could either be like having a very, very long winter if they're not suited to it, or a very extreme summer and roast the planet. In addition, the two bright blue stars and other very bright blue stars that form have much lower lifespans, because like in the millions of years, due to how bright they shine. So that means they burn up their fuel faster. So that would mean that it would be harder for life to form, because life on our own planet took billions of years to form, and there only has millions of years. So the likelihood of that last fact actually being true is not as much, but it's fiction, so we can always believe.
That was great, thank you. Good stuff. Hey, Gilly and Aaron, are you ready to go with the next object? This is a faint one, and so it's going to take a long exposure, I think.
Yep, we're
halfway
about
through.
about halfway through
Sorry.
a 3-minute exposure right now on that one. We just decided to get a head start on that. So yeah, we've been looking down here near Orion, over here near the Pleiades. Now we're over here. This is the prime meridian. Is that what we call this? I'm pretty sure that's what you call this.
Probably.
So this thing actually just crossed over the highest point in the sky. So this is, the best seeing we'll ever have for this guy. It's happening right now. And it's only 1 more minute remaining. It's kind of fun if you're watching at home. You can look along right here. We just have all these different data points about the object. Magnitude is actually brightness, how bright it is. And just to tell that story real briefly in 30 seconds, so a guy goes outside and says, those are the brightest. That's 1. And then he says, well, those are the next brightest. That's 2. And just by definition, now we have a system where the bigger the number is, the less bright it is, because the brightest things are 1. I'm pretty sure this is Hipparchus approximately 2,400 years ago, and we still use this awful system where a 10th magnitude thing is dim and a 1st magnitude thing is bright. So this is a very dim thing at 10th magnitude. Thank you, Hipparchus.
And the absolute brightest things are actually negative. So the sun has a magnitude of what, like negative 27?
It's about negative 27, that's right, yeah. And Venus is -4 or something like this. It's just silly. Oh, look at this. We've got stars that are really brightly saturated, but then right here, look at that. Can I get just a little bit more contrast, please?
All right, I think Philip can tell us about this one.
Yes, so this object is a globular cluster. And despite it's being called cataloged as NGC 2419, it's also called the Intergalactic Wanderer. Why is that? It was because that it was first initially thought that it's not a member of our galaxy, and that is a mistake. It's actually inside our galaxy. It's a globular cluster, which means that it composes of a lot of stars, like I would say, like 100,000 stars perhaps, and it is bounded by gravity into like a spherical shape, as you see in the image that the telescope just took. It's very dense towards the center, and globular clusters are orbiting our galaxies a little bit further away. For this one, it takes it about 3 billion years to finish a complete orbit around our galaxy, so it's orbiting very, very slowly. And it is about 300,000 light years away from us, meaning that the light we're seeing right now, it was from 300,000 years ago. And this globular cluster is 900,000 times the mass of our sun, and it's actually a little bit far from the center of our Milky Way galaxy. But it would be a very fun target for people in the Andromeda galaxy, a neighboring galaxy to our Milky Way galaxy, to observe. It will be very obvious to them that this galaxy, that this cluster is orbiting our galaxy, and it will be very fun for people in Andromeda Galaxy to observe.
Okay. Well, we're coming up to the end of our hour here at the open house. I wanted to just ask the stars one more time. Are there any objects that you absolutely need to show everyone tonight? Or shall we call it a night? Yes?
It looks like the pinwheel might be up. We haven't gotten the best picture we could ever get of a galaxy. I could try that one real quick.
All right, let's finish with the grand finale of the Pinwheel Galaxy.
Yeah.
And
With any luck.
yeah, with any luck, let's have a look at it. And tell you what, the stars have been doing a lot of work and doing the explanations. Do you guys want to talk a little bit about the pinwheel?
Say that again.
The stars have been doing a lot of the talking. And so would you guys like to explain the pinwheel as our last object for tonight?
I think pinwheel might be out of our... Yeah, we can't go to pinwheel. It's just outside.
Yep. Little
Sorry.
In that case, I'm going to say, guys, all of you on YouTube, thank you very much for coming tonight. I hope you've had a good look at the sky. I want to say thank you to the stars, and let me give some applause for being here tonight and sharing everything, and also to thank Gilly and Aaron, who not only came to be a virtual participant like the rest of us, but actually did go and open up the real telescopes under the real sky and led us through the star safari. So thank you very much, everybody. We're going to be having another open house in about a month's time. And so there we go. And of course, thank you to our beautiful telescopes as well. We're going to have another open house like this in about a month's time. And so please keep an eye on the Sommers-Bausch Observatory events page. We'll have the same sets of links there. And I want to say that if you joined us from any of our partner schools or organizations, special thanks for you guys for coming. And we hope we'll get to see you again too. Thank you.